What if I told you that time travel is already happening? That right now, your head is aging slightly faster than your feet? And that gravity isn't actually a pull. It's an illusion created by the fabric of the universe bending around us? Welcome to the mind-bending world of Albert Einstein. In 1905, a 26-year-old patent clerk completely broke our understanding of the universe, and then he rebuilt it. Today, we are breaking down his masterpiece, the theory of relativity. Relativity actually comes in two parts: special relativity, which deals with speed, and general relativity, which deals with gravity. Let's start with the one that messes with time. Special relativity, the speed limit of the universe. Before Einstein, scientists like Isaac Newton believed that space and time were absolute. A second is a second, a mile is a mile, no matter what. Einstein said, "Nope." He realized that the only true absolute in the universe is the speed of light, often written as c. In a vacuum, light travels at exactly 299,792,458 meters per second. Here is the weird part. Light always travels at that speed, no matter how fast you are moving. If you are standing still, a light beam races away from you at speed c. If you are chasing that light beam in a spaceship moving at 99% the speed of light, that beam still races away from you at exactly speed c. But wait, if speed is just distance divided by time, and the speed of light can never change, something else has to change. To keep the speed of light constant, space and time have to bend. This leads to a phenomenon called time dilation. Imagine you have a twin. You stay on Earth, but your twin hops into a rocket and flies through space at near the speed of light for what feels like 5 years. When they return, they have aged 5 years. But for you, looking at your calendar on Earth, 50 years might have passed. The faster you move through space, the slower you move through time. This isn't science fiction, it's a proven fact. And it led Einstein to his most famous realization, that mass and energy are essentially the same thing, locked together in the most famous equation in history. General relativity, the fabric of the universe. Okay, so special relativity is great if you're moving in a straight line at a constant speed. But the real universe has acceleration. It has planets, stars, and gravity. So 10 years later, in 1915, Einstein dropped general relativity. Newton said gravity was a magical pulling force between two objects. Einstein said gravity isn't a force at all. It's geometry. Imagine space and time are woven together into a four-dimensional fabric called spacetime. Think of it like a giant trampoline. If you place a heavy bowling ball in the middle, representing our sun, it creates a deep dip in the fabric. If you roll a marble, representing the Earth, across the trampoline, it doesn't move in a straight line. It gets caught in the dip and circles the bowling ball. The Earth isn't being pulled by a mysterious tether. It is simply following the natural curves of space. And remember how speed slows down time? Well, intense gravity does the exact same thing. This is called gravitational time dilation. If you've seen the movie Interstellar, you know exactly what I'm talking about. Sitting near a supermassive black hole bends space-time so much that 1 hour there equals 7 years back on Earth. Conclusion: why does this matter? You might be thinking, this is cool, but I'm not flying a spaceship or visiting a black hole anytime soon. Does this actually affect me? Yes, every single day. The GPS satellites orbiting the Earth right now are moving really fast. Special relativity, which means their onboard clocks tick slower than ours. But they are also far away from Earth's gravity, general relativity, which means their clocks should tick faster than ours. Engineers have to calculate both of Einstein's theories to sync satellite clocks with receivers on the ground. If they didn't account for relativity, your phone's GPS would drift by about 6 miles every single day. You'd never find that coffee shop. Einstein fundamentally changed how we view reality. He taught us that the universe isn't a rigid stage where events just happen. Space and time are flexible, dynamic, and intimately connected to the matter inside them. If this video bent your mind a little bit, hit that like button and subscribe for more deep dives into the universe. Let me know in the comments, if you could travel close to the speed of light, what year would you want to return to? Until next time, keep questioning everything.